So, I was trying to figure out what to have for lunch the other day,
Oh, a very critical decision.
obviously. So I flipped a quarter. And I kid you not, it came up heads 10 times in a row.
Wow, 10
10
times.
times. By flip 7, I was thinking, is the universe trying to tell me I really need a turkey sandwich? But it really got me thinking about probability and just how our brains completely fail to grasp truly endless sequences.
Oh, absolutely. I mean, infinity is just not something we are wired for on a daily basis.
Exactly. So today, for all of you listening to Intellectually Curious, we are doing a deep dive into some really fascinating source material. Advanced probability textbooks, historical measure theory papers, things like that.
Really heavy stuff.
The heavy stuff, yes. But our mission for you today is to explore this incredible mathematical wonder called Kolmogorov's 0-1 law. It basically says that in an infinite sequence of independent events, certain outcomes are either absolutely guaranteed to happen or completely impossible.
Right, there's absolutely no in between.
0-1. Okay, let's unpack this.
So at its core, Kolmogorov's law, named after Andrei Nikolaevich Kolmogorov, deals with what we call tail events. And these happen within independent sigma algebras.
Which sounds completely terrifying.
It does sound heavy, I know. But you can just think of sigma algebras as the mathematical rulebooks. They just tell us which events in an infinite sequence we can actually measure.
Okay, so a tail event is an outcome where the probability, according to that rulebook, is either exactly 1, meaning it almost surely happens, or exactly 0.
Precisely. It almost surely will not happen.
The sources actually use a great example for this to help us visualize it, the classic infinite coin toss.
A staple of probability.
Right, so imagine you are flipping a coin forever. The event of getting, say, 100 consecutive heads infinitely many times is a tail event.
And what's fascinating here is that the ultimate outcome of a tail event does not depend on any finite initial segment. So even if you completely remove the first million tosses.
Right, because infinity minus a million is still infinite.
Exactly. You can still determine if the event happens regardless of what happened in those early flips.
Which is just wild to think about. Spotting those kinds of ultimate patterns in massive data streams requires incredible processing power. Which actually reminds me of our sponsor, Embersilk.
Oh yeah, a perfect tie-in.
If you are building systems that need to parse massive amounts of data, or if you need help with AI training, automation integration, or software development, they are the experts. Check out embersilk.com to uncover where agents could make the most impact for your business or your personal life. Because, let's face it, we cannot all sit around calculating infinite probabilities by hand.
Very true. And you really would need that AI because there is a wonderful little paradox in Kolmogorov's law that our textbook sources highlight.
Yes, this blew my mind. Here's where it gets really interesting. The sources point out that it is actually quite easy to use this law to prove an event has a probability of exactly 0 or exactly 1.
Yeah.
But it is surprisingly hard to figure out which of those two extremes is the actual answer.
That is the grand paradox of it all. It is fundamentally an existence theorem. It proves the limit of 0 or 1 must exist purely based on the structural independence of the sequence.
So we know it is definitively yes or definitively no, but the math refuses to tell us which.
Right, because it abstracts away all the specific finite mechanics of those early events. It does not give you the actual calculation to find the final value. It's like knowing for a fact that a box contains either $1 million or absolutely nothing, but the rule that tells you this will not give you the key to open it.
That is a perfect analogy.
And just to clear up a common mix-up in the literature while we are at it, when we say tail events here, we mean convergence. Whether an infinite sequence settles into a definitive state, this has absolutely nothing to do with fat tails.
Oh, right, like you hear about in finance.
Yes, fat tails are just statistical outliers or tail risks. Totally different concept. Kolmogorov's tails are about ultimate structural certainty. We actually see this applied beautifully in percolation theory.
Which models how materials connect or fluids flow, right?
Yes, it guarantees connectivity. It helps us identify infinite clusters, essentially proving that certain materials will always form infinite connected pathways. It is exactly how we develop advanced new materials and superconductors.
So it is a mathematical guarantee of connectivity and structure.
It is. And if we connect this to the bigger picture, imagine applying this concept to the trajectory of human knowledge and innovation.
I like where this is going.
If you treat human discoveries as an infinite sequence of independent events, Kolmogorov's law implies that certain ultimate outcomes are not just likely, they're mathematical tail events.
Wow.
It suggests that absolute universal understanding and the total solving of our greatest challenges might actually be a mathematical certainty, guaranteed to happen regardless of the finite stumbles we make today.
That is an incredible thought, an unbreakable mathematical guarantee of human progress, and an amazing place to wrap up. If you enjoyed this deep dive, please subscribe to Intellectually Curious.
And hey, leave a 5-star review if you can.
Yes, it really does help get the word out. Thanks for tuning in, everyone. Remember, we live in a universe built on beautiful underlying order, and our human capacity to solve complex problems and build a brilliant future is truly limitless. Keep asking questions and keep exploring.